Hello, ladies and gents, boys and girls. Welcome to another episode of ML for Noobs. Today, we're going to be tackling lesson number 2. All right, now I will have you notice that the quality for this video is going to be much better than the last one because, well, the last video I was actually recording the audio from the video through my microphone, and so the quality was, well, it was crap. And this time, figured out how to record directly from the video itself. So hopefully you're going to appreciate the much higher quality audio that you get from the video that I play. Anyway, without further ado, let's dive right into lesson number 2 of 7 lessons in the Fast AI course. This is the 2019 edition. So, Jeremy Howard, take it away. I'm going to play this a bit faster than maybe 2x. I usually like playing it at 2x just because it gives me a better understanding. I actually feel like my understanding hurts when I play it slower.
Welcome to lesson 2, where we're going to be taking a deeper dive into computer vision applications and taking some of the amazing stuff that you've all been doing during the week and going even further. So let's take a look. Before we do, a reminder that we have these 2 really important topics on the forums. They're pinned at the top of the forum category. One is fact resources and official course updates. This is where if there's something useful for you to know during the course, we will post there. Nobody else can reply to that thread. So if you set that thread to watching and to notifications, you're not going to be bugged by anybody else except stuff that we think you need to know for the course. And it's got all the official information about how to get set up on each platform. Please note, a lot of people post all kinds of other tidbits about how they've set up things on previous solutions or previous courses or other places. I don't recommend you use those because these are the ones that we're testing every day and the folks involved in these platforms are testing every day, and they definitely work. Okay, so I would strongly suggest you follow those tips. And if you do have a question about using one of these platforms, please use these discussions, not some other topic that you create. This way, people that are involved in these platforms will be able to see it and things won't get messy. And then secondly, for every lesson, there will be an official updates thread for that lesson. So lesson 1 official updates and the same thing. Only Fast AI people will be posting to that. So you can watch it safely, and we'll have all the things like videos, notebooks, and so forth. And they're all wiki threads, so you can help us to make them better as well. So I mentioned the idea of watching a thread, so this is a really good idea, is that you can go to a thread, like particularly those official update ones, and click at the bottom, watching. Okay, and if you do that, that's going to enable notifications for any updates to that thread, particularly if you go into, click on your little username in the top right, preferences, and turn this on, that'll give you an email as well. Okay, so any of you that have missed some of the updates so far, go back and have a look through, because we're really trying to make sure that we keep you updated with anything that we think is important. One thing which can be more overwhelming is even now, after just 1 week, the most popular thread has 1.1 thousand replies. So that's an intimidatingly large number. I've actually read every single one of them, and I know Rachel has, and I know Sophia has, and I think Francisco has, but you shouldn't need to. What you should do is click summarize this topic, and it'll appear like this, which is all of the most liked ones will appear, and then there'll be view 31 hidden replies or whatever in between. So that's how you navigate these giant topics. That's also why it's important you click the like button, because that's the thing that's going to cause people to see it in this recommended view. So when you come back to work, hopefully you've realized by now that on the official course website, course-v3.fast.ai, you'll click returning to work, you'll click the name of the platform you're using, and you will then follow the 2 steps. Step 1 will be how to make sure that you've got the latest notebooks, and step 2 will be how to make sure you've got the latest Python library software. Okay, they all look pretty much like this, but they're slightly different from platform to platform, so please don't use some different set of commands you read somewhere else, only use the commands that you read out here, and that will make everything very smooth. If things aren't working for you, if you get into some kind of messy situation, which we all do, just delete your instance and start again. Unless you've got mission critical stuff there, it's the easiest way just to get out of a sticky situation, and if you follow the instructions here, you really should find it works fine. So this is what I really wanted to talk about most of all, is what people have been doing this week. If you've noticed, and a lot of you have, there's been 167 people sharing their work. And this is really cool because it's pretty intimidating to put yourself out there and say, like, I knew all this, but here's what I've done. And so examples of things I thought were interesting was figuring out who's talking. Is it Ben Affleck or Joe Rogan? I thought this was really interesting. This is actually very practical. I wanted to clean up my WhatsApp downloaded images to get rid of memes. So I actually built another neural network. I mean, how cool is that to say, like, oh yeah, I've got something that cleaned up my WhatsApp. It's a deep learning application I wrote last week. Why not? Like, it's so easy now. You can do stuff like this. And then there's been some really interesting projects. One was looking at the sounds data that was used in this paper. And in this paper, they were trying to figure out what kind of sound things were. And they got, as you expect, since they published the paper, they got a state-of-the-art of nearly 80% accuracy. Ethan Sutton then tried using the lesson 1 techniques and got 80.5% accuracy. So I think that's pretty awesome. Best as we know, it's a new state-of-the-art for this problem. Maybe somebody since then has published something we haven't found it yet. They take all of these with a flat grain of salt. But I've mentioned on Twitter, and lots of people follow me, so if everybody knew that was a much better approach, I'm sure somebody would have said so. This one is pretty cool. Suvash has a new state-of-the-art accuracy for Devanagari text recognition. I think he's got it even higher than this now. And this is actually confirmed by the person on Twitter who created the data set. I don't think he had any idea. He just posted, hey, here's a nice thing I did. And this guy on Twitter was like, oh, I made that data set. Congratulations, you put a new record. So that was pretty cool. I really like this post from Elena Harley. She describes in quite a bit of detail about the issue of metastasizing cancers and the use of point mutations and why that's a challenging, important problem. And she's got some nice pictures describing like what she wants to do with this and like how she can go about turning this into pictures. And this is a cool trick, right? It's the same with this sounds one, turning sounds into pictures and then using the lesson one approach. And here it's turning point mutations into pictures and then using the lesson one approach. And what did she find? It seems that she's got a new study result by more than 30%, beating the previous best. Somebody on Twitter who's a VP of the genomics analysis company looked at this as well and thought it looked to be associated in this particular point mutation one as well, so that's pretty exciting. So you can see, when we talked about last week, this idea that this simple process is something which can take you a long way. It really can. I will mention that something like this one in particular is using a lot of domain expertise, like figuring out what picture to create. I wouldn't know how to do that because I don't even really know what a point mutation is, let alone how to create something that visually is meaningful that a CNN would recognize. But the actual deep learning side is actually pretty straightforward. Another very cool result from Simon Willison and Natalie Down. They created a Cougar or Not web application over the weekend and won the Science Hack Day award in San Francisco. And so I think that's pretty fantastic. So lots of examples of people doing really interesting work. Hopefully this will be inspiring to you to think, wow, this is cool that I can do this, what I've learned. It can also be intimidating to think like, wow, these people are doing amazing things. But it's important to realize that out of the thousands of people doing this course, I'm just picking out the kind of a few of the really amazing ones. And in fact, Simon is one of these very annoying people like Christine Payne, who we talked about last week, who seems to be good at everything he does. He created Django, and it's one of the most popular web frameworks. He founded a very successful startup, and blah, 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 blah. So, one of these really annoying people who tends to keep being good at things, and now turned out he's good at deep learning as well. So, that's fine. Simon can go and win a hackathon on his first week of playing with deep learning. Maybe it'll take you 2 weeks to win your first hackathon. That's okay. And I think it's important to mention this because there was this really inspiring blog post this week from James Dellinger, who talked about how he created a bird classifier using techniques from Lesson 1. But what I really found interesting was at the end, he said he nearly didn't start on deep learning at all because he went to the scikit-learn website, which is one of the most important libraries of Python, and he saw this. And he described in his blog post how he was just like, that's not something I can do, it's not something I understand. And then this kind of realization of like, oh, I can do useful things without reading the Greek. So I thought that was a really cool message. And I really want to highlight actually Daniel Armstrong on the forum, I think really shows is a great role model here, which is he was saying, I want to contribute to the library. And I looked at the docs and I just found it overwhelming. And his next message one day later was, I don't know what this is, I didn't know how to do it caught me off guard, my brain shut down. But I love the way it forces me to learn so much. And then one day later, I just submitted my first pull request. So I think that's awesome, right? It's this kind of like it's okay to feel intimidated. There's a lot, right? But just pick one piece and dig into it. Try and push a piece of code or a documentation update or create a classifier or whatever. So here's lots of cool classifiers people have built. It's been really, really inspiring. Trinidad and Tobago Islander versus Masquerader classifier, a zucchini versus cucumber classifier. This one is really nice. This is taking the dog and cat breeds thing from last week and actually doing some exploratory work to see what the main features were and discovered that they could create a hairiness and classifier. And so here we have the most hairy dogs and the most bald cats. So there are interesting things you can do with interpretation. Somebody else on the forum took that, did the same thing to anime to find that they had accidentally discovered an anime hair color classifier. We can now detect the new versus the old Panamanian buses correctly. Apparently these are the new ones. I much prefer the old ones, but maybe that's just me. This was really interesting. Henry Palachi discovered that he can recognize with 85% accuracy which of 110 countries a satellite image is of, which is definitely going to be beyond human performance of just about anybody. Like I can't imagine anybody who can do that in practice. So that was fascinating. Batik cloth classification with 100% accuracy. David Ward did this interesting one. He actually went a little bit further using some techniques we'll be discussing in the next couple of courses to build something that can recognize complete or incomplete or foundation buildings and actually plot them on aerial satellite view. So lots and lots of fascinating projects. So don't worry, it's only been 1 week. That doesn't mean everybody has to have had a project out yet. A lot of the folks who already have a project out have done a previous course, so they've got a bit of a head start. But we'll see today how you can definitely create your own classifier this week.
Okay.
So from today up, we dig a bit deeper into really how to make these computer vision classifiers in particular work well. We're then going to look at the same thing for text. We're then going to look at the same thing for tabular data, so kind of like more like spreadsheets and databases. Then we're going to look at collaborative filtering, so kind of recommendation system. That's going to take us into a topic called embeddings, which is basically a key underlying platform behind these applications. That will take us back into more computer vision and then back into more NLP. So the idea here is that it turns out that it's much better for learning if you kind of see things multiple times. So rather than being like, okay, that's computer vision, you want to see it again for the rest of the course, we're actually going to come back to the 2 key applications, NLP and computer vision, a few weeks apart, and that's going to force your brain to realize like, oh, I have to remember this. It's not just something I can throw away. So we are, for people who have more of a hard sciences kind of background in particular, a lot of folks find this hey, here's some code, type it in, start running an approach, rather than here's lots of theory approach, confusing and surprising and odd at first. And so for those of you, I just want to remind you, this basic tip, which is keep going. Right? You're not expected to remember everything yet. You're not expected to understand everything yet. You're not expected to know why everything works yet. You just want to be in a situation where you can enter the code and you can run it and you can get something happening and then you can start to experiment and you kind of get a feel for what's going on and then push on, right? Most of the people who have done the course and have gone on to be really successful watch the videos at least 3 times. So they're going to go through the whole lot and then go through it slowly the second time and then go through it really slowly the third time.
Okay.
And consistently hear them say I get a lot more out of it each time I go through. So don't pause lesson 1 and stop until you can continue.
Way to set the right
So
expectations.
this approach is
Jeremy.
based on a lot of academic research into learning theory, and one guy in particular, David Perkins from Harvard, has this really great analogy. He's a researcher into learning theory. He describes this approach of the whole game, which is basically if you're teaching a kid to play soccer, you don't, first of all teach them about, how the friction between a ball and grass works, and then teach them how to sew a soccer ball with their bare hands, and then teach them the mathematics of parabolas when you kick something in the air. No, you say, here's a ball. Let's watch some people playing soccer. Okay, now we'll play soccer. And then you gradually over the following years learn more and more so that you can get better and better at it. So this is kind of what we're trying to get you to do is play soccer, which in our case is to type code. Look at the inputs and look at the outputs. Okay, so let's dig into our first notebook, which is called Lesson 2 Download. And what we're going to do is we're going to see how to create your own classifier with your own images. So it's going to be a lot like last week's text detector, but it'll detect whatever you like. So it'll be like those some of the examples we just saw. How would you create your own Panama bus detector from scratch? So this is inspired, the approach is inspired by Adrian Rosebrock, who has a terrific website called Image Search, and he has this nice explanation of how to create a data set using Google Images. So that was definitely an inspiration for some of the techniques we use here, so thank you to Adrian. And you should definitely check out his site, it's really full of lots of good resources. So here we are. So we are going to try to create a teddy bear detector. Thanks. We're going to try and make a teddy bear detector, and we're going to try and separate teddy bears from black bears from grizzly bears. This is very important. I have a 3-year-old daughter, and she needs to know what she's dealing with. In our house, you'd be surprised at the number of monsters, lions, and other terrifying threats that are around, particularly around Halloween. And so we always need to be on the lookout to make sure that the thing we're about to cuddle is in fact a genuine teddy bear. Okay, so let's deal with that situation as best as we can. So our starting point is to find some pictures of teddy bears so we can learn what they look like. So I go to images.google.com, and I type in teddy bear, and I just scroll through until I kind of find a goodly bunch of them. And it's like, okay, that looks like plenty of teddy bears to me. So then I go back to here, so you can see the search and scroll. Go to Google Images and search. And the next thing we need to do is to get a list of all of the URLs there. And so to do that, you back in your Google Images, you hit Control-Shift-J or Command-Option-J, and you paste this into the window that appears. So I've got Windows, so I go Control-Shift-J, paste in that code. This is a JavaScript console. For those of you who haven't been JavaScript before, I hit Enter, and it downloads a file for me. So I would call this teddies.txt, and press Save. Okay, so I now have a file of teddies, or URLs. Okay. So then I would repeat that process for black bears and for brown bears, since that's the classifier I would want. I put each one in a file with an appropriate name. So that's step 1. So step 2 is we now need to download those URLs to our server. Because remember, when we're using Jupyter Notebook, it's not running on our computer, it's running on SageMaker or Cressel or Google Cloud or whatever. So to do that, we start running some Jupyter cells. So let's grab the file library, and let's start with black bears. I've already got my black bears URL. So I'll click on this cell for black bears, and I'll run it. So here I've got 3 different cells with doing the same thing but different information. This is one way I like to work with Jupyter Notebook. It's something that a lot of kind of people with a more strict scientific background are horrified by. This is not reproducible research. I actually click here and I run this cell to create a folder called black and a file called URLs black for my black bears. I skip the next 2 cells, and then I run this cell to create that folder. Okay. And then I go down to the next section and I run the next cell, which is download images for black bears. Alright, so that's just going to download my black bears to that folder. And then I'll go back and I'll click on teddies and I run that cell, and then scroll back down and I'll run this cell. And so that way I just go back and forth to download each of the classes that I want. Very manual, but for me, I'm very iterative and very experimental. That works well for me. If you're better at how to planning ahead than I am, you can write a proper loop or whatever and do it that way. So when you see my notebooks and see things where there's these kind of like configuration cells doing the same thing in different places, this is a strong sign that I didn't run this in order. I clicked one place, went another, and that, went back, went back, went back. And for me, I'm an experimentalist. I really like to experiment in my notebook. I treat it like a lab journal. I try things out and see what happens, and so this is how my notebooks end up looking. It's a really controversial topic. Like for a lot of people, they feel this is like wrong. That you should only ever run things top to bottom. Everything you should do should be reproducible. For me, I don't think that's the best way of using human creativity. I think human creativity is best inspired by trying things out, seeing what happens, and feeling around. So you can see how you go. See what works for you. So that will download the images to your server. It's going to use multiple processes to do so. And one problem there is if there's something goes wrong, it's a bit hard to see what went wrong. So you can see in the next section there's a commented out section that says max workers equals 0, and that'll do it without spinning up a bunch of processes, and will tell you the errors better. So if things aren't downloading, try using the second version. Okay, so text. So I grabbed a small number of each, and the next thing that I found I needed to do was to remove the images that aren't actually images at all. And this happens all the time. There's always a few images in every batch that are corrupted for whatever reason. Google image tried to told us that this URL had an image, but actually it doesn't anymore. So we've got this thing in the library called verify images, which will check all of the images in a path, and will tell you if there's a problem. If you say delete equals true, it will actually delete it for you. Okay, so that's a really nice, easy way to end up with a clean data set. So at this point, I now have a bears folder containing a grizzly folder and a teddies folder and a black folder. In other words, I have the basic structure we need to create an image data bunch to start doing stick learning.
Okay, I really have to try this myself because this looks. I've always wondered how this actually works. Like, how can they actually get this thing working? And so I really want to see how this works myself. So, teddy bear. Let's go ahead. And the idea is that you would just scroll all the way down until you have like a nice little collection of bears here that we can use. And wow, there's a lot of variety in the bears they have here. Show more results. All right, I'm gonna get me a really nice collection here. And then what I'm gonna do is go to the notebook. That's this guy over here. And all right, so we're doing the same thing we did earlier, except now we're gonna copy this bad boy and we're gonna paste them here. All right, so let's just paste that there and make sure that we allow pop-ups. All right, and then we're just gonna save this file. All right, so that's our file right there. All right, and then And so this is teddy bears. Okay. Let's go ahead and open that file and just make sure that we rename it as teddy bears. Alright, so that's teddy bears. And we're gonna do the exact same thing with the others. So that's teddy bears. Alright, we're gonna call them teddies. Window.open, then you can run the following command. Alright, choose an appropriate name for your labeled images. Okay. And then there's black bears and grizzly bears. Alright, let's go ahead and get us some black bears. Okay. Again, plenty of variety here. I'm seeing so many different types, so many different backgrounds. There's even some text here. Oh man, good luck with that. There's some brown black bears. Why are these guys brown? They don't look like black bears to me. Hit show more results and then keep going a little bit. Alright, so at this point I think we've got us a nice collection here. And we can go ahead and paste the same script and save that file too. So this is gonna be black.txt. So this was Teddy, that was black. Now finally I'm just gonna do brown bears as well. Same thing. No, black teddies and grizzly bear. That's what you want. You want grizzly bear. Alright. Alright. Let's go all the way down. Very nice collection here. Let's show more results once more. Get all those juicy images. And I think we're good to go. Save that. Alright, and that's gonna be grizzly.txt. Alright, so at this point we've got all of them. We can move on. So what am I supposed to do? I'm not really using that. So here, choose an appropriate name for your labeled images. You can run these steps multiple times to create different labels. So folder equals black, file equals URLs underscore black. Okay, so run that. Now it's going to go ahead and create that folder for us. So here, I should be able to go to fastai/data and see my folder. So let's take a look at what that looks like. I don't see it. Alright, isn't it supposed to be here? Path, okay. You know what, I'm just gonna go here and I'm gonna do find from here on out anything with the name beers. Alright, let's see what we find. There it is. Alright, so it's in this directory here. So let's go ahead and go there. Alright. So here we can see that the black directory has been created for us, and the file is supposed to be URLs underscore black .csv. And so when I go to black here, let me hit black if I can spell it. Here I need to paste in my, what is it called, urls underscore black .csv, and I'm just going to copy the file that I got right here. Just copy that and paste it in here. I'm just going to paste it and save that file. So now we're done. So if we want to see what that looks like, you can see these are the first few lines of that file. So we're good. All right. So now when I say path ls, I can say we have data, and then finally upload your urls file. You just need to press upload in your working directory and select your file. Oh, okay. Upload each one of the displayed files. What's the path again? Data/bears. Oh, okay, so I put it in the wrong directory. Let me move up one directory. Alright, so you can see urls underscore black is there, and I'm just going to go ahead and do the same for the rest of these guys. So grizzly. Alright, so that's saved. And the last one is urls underscore teddy or teddies.csv. Let me get that file in there as well. Alright, that's done. So at this point we have all three files set up, and we should be good. So when I do path ls, I can see that my three files are there. That's great. So now you have classes set up, and we can do download images path/file. So let's go ahead and do that. We set max pics at 200, so I assume that's going to mean we're going to get a maximum of 200. Captain Obvious to the rescue. Alright, so you can see a couple of these didn't actually work out, so that's okay. So if you have problems, download, try with max workers. No problems there, but it looks like a few of these didn't work out. So we can remove the images that didn't work out. So let's see what happens here. Alright. Okay, so we got 197, so that's pretty good. So now we're going to go back and do the same thing. So that was black. We got all our black images. So if we go to black now, you can see we've got all our images. So let's see how many of these are. 187. Okay. All right, let's do the same for teddies. And all right, we're going to do teddies now. Download images. Daydream white teddy bear. Man, this feels like a hack. I never knew you could download Google Images like this. I always thought it was something they would throttle. I didn't realize it was so simple. I mean, I know technically it's possible. I just I didn't realize it's so simple. All right, so let's do this. Okay. Oh, it looks like they all worked. That's pretty good. So if we go here, we go to Teddy's. I think that's the one we just did. No. Just did. Which one did I just do? What's the second one? Teddy's, yeah. Yeah, we just did Teddy's. What's the deal? So we go to Teddy's. It's empty. Where'd it go? It didn't put it in black, did it? Huh. We got 239 now. What on earth is going on? Alright, looks like I didn't execute the cells in the right order. Crap. Okay, you know what? I'm just gonna go ahead and delete the 3 folders. Do that again. Okay, and now we're gonna create the folders individually. So you run that, and then you run this. You run path.ls. You can see you have your black folder created. All right, so we created the folder, and then we're gonna do it for the other guys. So create the folder and create Grizzly as well. So now we should have these 3 folders. All right. And then we're ready to download the images. So looks like this already takes care of, right? So it says path/file, and so obviously the file here is going to be urls_grizzly. Okay, all right, I see what's going on. So we're going to start with Grizzly just because that was the last one there. So now when I run this, it's going to give me the URLs black. Okay, so right now we're all right. We got URLs black. Let's go ahead and download our black images now. And we're going to do the same thing. All right, so here you're going to iterate through the classes. So you need to have downloaded all of them by now. So let me go ahead and do the same thing. So teddies, just make sure that says teddies, and go ahead and download all the teddy images. Oh man, I need to run dest again. Don't tell me that happened. It's sent it to the Grizzly folder. Oh, come on, Jeremy, what are you doing, man? You're driving me nuts. Alright, that got messed up again. Alright, you know what? Let me delete everything in the Grizzly folder. You have to download that one again, I'm afraid. I can't even cd Grizzly. Alright, I'm just gonna delete everything here. Okay. So now what we're gonna do is we're gonna run this again. Okay? We're gonna download the images again. And make sure we're doing this properly. So black, we're going to start with black, and we're going to download. So just make sure that says black, make sure the path says black. So it's not doing that now, so let's set that. Destination is black. All right, let's download. Third time's a charm, come on. Alright, so I think that's about as far as we're gonna get. Now we're gonna do it with teddies. So do that, do this, and then verify that this says teddies, and then run this again. And let's go ahead and do it one last time for our Grizzlies. So run that, run this, and then verify Grizzlies. Alright, ready to download. Let's download. And then at this point, it's going to iterate through our classes. Alright, at this point, it's going to iterate through our classes and remove the extra images. So if I take a look here, you can see that each of these folders has, so Teddy's has about 200, and Grizzly is another 200, and black has another. So yeah, all right, it tells us that things are going all right. Let's go ahead and run this. All right, removing a bunch of images. All right, okay. All right, a bunch of them are going away. So yeah, we're just left with the good stuff. Let's go ahead and run. Let's view the data. Let's take a look at some images. If you've already cleaned your data, what's cleaned your data mean? Classes looks alright. Let's see a badge. Show us a badge, come on. Why is it taking so long? Alright. Black looks kind of brown. Alright, these definitely look black. That's definitely a teddy bear. It's a grizzly. It's a grizzly looking at a telescope. Alright, looks good. Yeah, this looks like a good batch. So here we're just doing some verification. Alright, train and valid. So we can see we've got training data is 440 and then validation is 110. Alright, so at this point we're ready to go. Let's go ahead.
So let's go ahead and do that. Now,
Play the video.
Very often when you download a data set from like Kaggle or from some academic data set, there will often be a folder called train and a folder called valid and a folder called test, right, containing different data sets. In this case, we don't have a separate validation set because we just grab these images from Google search, right? But you still need a validation set, otherwise you don't know how well your model is going. And we'll talk more about this in a moment. So whenever you create a data bunch, if you don't have a separate training and validation set, then you can just say, okay, well the training set is in the current folder, because by default it looks in a folder called train, and I want you to set aside 20% of the data, please. So it's going to create a validation set for you automatically and randomly. You'll see that whenever I create a validation set randomly, I always set my random seed to something fixed beforehand. This means that every time I run this code, I'll get the same validation set. So in general, I'm not a fan of making my machine learning experiments reproducible, i.e. ensuring I get exactly the same result every time. The randomness is, to me, really important. It's a really important part of finding out, is your solution stable? You know, is it going to work like each time you run it? But what is important is that you always have the same validation set. Right? Otherwise, when you're trying to decide, has this hyperparameter change improved my model, but you've got a different set of data you're testing it on, then you don't know, maybe that set of data just happens to be a bit easier. Right? So that's why I always set the random seed here. So we've now got, let's run that cell. So we've now got a data bunch, and so you can look inside at the data.classes, and you'll see these are the folders that we created. So it knows that the classes, or so by classes we mean all the possible labels, black bear, grizzly bear, or teddy bear. We can run show batch, and we can take a little look. And it tells us straight away that some of these are going to be a little bit tricky. So this is not a photo, for instance. Some of them kind of crop funny. Some of them might be tricky, like if you ended up with a black bear standing on top of a grizzly bear, that might be tough. Anyway, so you can kind of double check here data.classes, there they are. Remember C is the attribute which classifier tells us how many possible labels there are. We'll learn about some other more specific meanings of C later. We can see how many things are in our training set. We can see how many things are in our validation set. So we've got 473 training set, 141 validation set. So at that point we can go ahead. You'll see all these commands are identical to the PET classifier from last week. We can create our CNN, our convolutional neural network, using that data. I tend to default using a ResNet 34, and let's print out the error rate each time and run fit one cycle 4 times and see how we go. And we have a 2% error rate. So that's pretty good. I personally, sometimes it's easy for me to recognize a black bear from a grizzly bear, but sometimes it's a bit tricky. This one seems to be doing pretty well. Okay, so after I kind of make some progress with my model and things looking good, I always like to save where I'm up to. This saves me the 54 seconds of going back and doing it again. And as per usual, we unfreeze the rest of our model. We're going to be learning more about what that means during the course. And then we run the learning rate finder and plot it. It tells you exactly what to type. And we take a look. Now, we're going to be learning about learning rates today, actually. But for now, here's what you need to know. On the learning rate finder, what you're looking for is the strongest downward slope that's kind of sticking around for quite a while, right? So this one here looks more like a bump, but this looks like an actual downward slope to me. So it's kind of like, it's something you're going to have to practice with and get a feel for, like which bit works. So like if you're not sure, is it this bit or this bit, try both learning rates and see which one works better. Okay, so I've been doing this for a while and I'm pretty sure this looks like where it's really learning properly. So I would pick something, okay, here it's not so steep, so I would probably pick something back here for my learning rate. So you can see I picked 3 neg 5, so somewhere around here. That sounds pretty good. So that's my bottom learning rate. So my top learning rate, I normally pick 1 neg 4 or 3 neg 4. It's kind of like I don't really think about it too much. That's a rule of thumb. It always works pretty well. One of the things you'll realize is that most of these parameters don't actually matter that much in detail. If you just copy the numbers that I use each time, the vast majority of the time it'll just work fine. And we'll see.
Okay, so the results are in, and it looks like we're closer to 4.5% error rate. So not as good as his, but yeah, we're there. We're going to run the learning rate finder after we run unfreeze. And I'm just going to keep this going while we watch the video.
Places where it doesn't today. Okay, so we've got a 1.4% error rate after doing another couple of plots. So that's looking great. So we've downloaded some images from Google Image Search, created a classifier, we've got 1.4% error rate. Let's save it. And then as per usual, we can use the classification interpretation class to have a look at what's going on. And in this case, we made one mistake. There was one black bear classified as grizzly bear. So that's a really good step.
Really
but possibly you could do even better if your data set was less noisy. Like maybe Google image search didn't give you exactly the right images all the time. So how do we fix that? And so we want to clean it up. And so combining a human expert with a computer learner is a really good idea. Almost nobody, but very, very few people publish on this. Very, very few people teach this. But to me, it's like the most useful skill, particularly for you. Most of the people watching this are domain experts, not computer science experts. And so this is where you can use your knowledge of point mutations in genomics or Panamanian.
All right, so before it goes deep on that, let me just hit this out real quick. So again, we're trying to do the same thing that he did, but with a very different data set. So based on what he was talking about, you want to find the most consistent downward slope. It looks to me like this is probably closer to 1E5 to 1E4, or maybe just right here. So between 1E4 and 1E3. So I'm just going to do that. 1E4 to 1E3, and let's see if we can't beat the earlier rates. Remember, that was 4.5%. That's the rate we're trying to beat, and let's see if we can get better results. Okay, so we got 9%, and it's actually worse. Okay, what about minus, I don't know, let's say 9E3 to 3E3. 9E3 to 3E3. What's that going to look like? So that's just going to be this bit right here. Just that part there. What? 65%? Okay, there is something wrong there. Alright, you know what? I'm just going to go 1E6 to 1E3. Alright, we're just going to go crazy here. 1E6 to 1E3. Let's see what that looks like. Oh, it's not so gray here. I don't think that's going to be... Alright, it's actually significantly worse. Okay. 1E4 to 1E3. Alright, final attempt. Just can't stand the idea of losing here. I don't even know what I'm losing. I'm just changing numbers randomly. All right, so 36%. That's not looking too promising. 30% error rate. That's pretty crap. I gotta say that just looks like crap. I don't know how his is so much better, but hey, there you go. Learn.load stage 2. I'm gonna stick with stage 1 here because we got much better results on stage 1. I don't know if it's because of fit 1 cycle 2 versus we used 4 earlier. Maybe that's it, maybe that's the reason. I'm gonna try with 4, see what happens here. I don't know if that's gonna make a difference or not, but hey, who knows, right? 4 epochs versus just doing 2. I remember it was close to 30% earlier. Let's see what we get now. Nah, it doesn't look like it's gonna be much better. Yeah, it's 27%. Alright, you know what? Doesn't matter. I'm gonna stick with stage 1 here, so we're gonna go ahead and load stage 1. And then we're gonna run our classification thing here. Take a look at our confusion matrix. Alright, so yeah, we got 5 grizzlies categorized as black, which is actually 5 blacks categorized as we predicted as grizzlies, and I don't blame it because honestly it looked like a mess. So let's go back to what he was talking about.
Buses or whatever. So let's see how that would work. What I'm going to do is, do you remember the plot top losses from last time where we saw the images which it was like either the most wrong about or the least confident about? We're going to look at those and decide which of those are noisy. Like if you think about it, it's very unlikely that if there is some mislabeled data, that it's going to be predicted correctly and with high confidence. That's really unlikely to happen. So we're going to focus on the ones which the model is saying either it's not confident of or it was confident of and it was wrong about. They are the things which might be mislabeled. Big shout out to the San Francisco Fast AI study group who created this new widget this week called the Firewall Editor. So that's Zach and Jason in Francisco built this thing where we basically can take the top losses from that interpretation object we just created, right? And then what we're going to do is we're going to say, okay, that returns top losses. It's not just plot top losses, but it's also just top losses. And top losses return 3 things: the losses of the things that were the worst, and the indexes in the data set of the things that were the worst. And if you don't pass anything at all, it's going to actually return the entire data set, but sorted. So the first things will be the highest losses. As we'll learn during the course, we'll keep seeing during the course, every data set in FastAI has an X and a Y. And the X contains the things that are used to, in this case, get the images. So this is the image file names, and the Ys will be the labels. So if we grab the indexes and pass them into the data set X, this is going to give us the file names of the data set ordered by which ones had the highest loss.
Okay, I had a really confusing time on the last setup, the last practice, where I wasn't able to figure out where the actual path was, and this kind of explains it. So he's returning top losses, which we were able to find as well, sorted by, highest loss to lowest. But this thing, data.valid ds.x, and then pass the IDs, I didn't know that you could do that. And so top loss paths would return a bunch of paths. That's pretty awesome. I didn't know about that.
So which ones it was either confident and wrong about or not confident about. And so we can pass that to this new widget that they've created called the file deleter widget. So just to clarify, this top loss paths contains all of the file names in our dataset. When I say in our dataset, this particular one is in our validation dataset. So what this is going to do is it's going to clean up mislabeled images or images that shouldn't be there. And we're going to remove them from our validation set so that our metrics will be more correct. You then need to rerun these two steps, replacing valid DS with train DS, to clean up your training set to get the noise out of that as well. So that's a good practice to do both. We'll talk about test sets later as well. If you also have a test set, you'll then repeat the same thing. So we run file deleter, passing in that sorted list of paths. And so what pops up is basically the same thing as plot top losses. So in other words, these are the ones which it's either wrong about or at least confident about. And so not surprisingly, this one here does not appear to be a teddy bear or a black bear or a brown bear. Right? So this shouldn't be in our data set. So what I do is I whack on the delete button. Okay, and all the rest do look indeed like theirs, and then so I can click confirm, and it'll bring up another 5. What's that? That's not a bear, is it? Does anybody know what that is? I'm going to say it's not a bear. Delete, confirm. Oh, not there. Well, that's a teddy bear, I'll leave that. That's not really, I'll get rid of that one. Confirm. Okay, so what I tend to do when I do this is I'll keep going confirm until I get to a couple of screenfuls of things that all look okay, and that suggests to me that I've kind of got past the worst bits of the data. Okay, and that's it. And so now you can go back, I want to do it for the training set as well, and retrain your model.
Wait, I gotta try this. Alright, so let's go ahead and do this ourselves. And in order to clean, you need to create a new data set without the split. The video lecture demonstrated the use of the DS type param, which no longer has any effect. See the thread for more details. Okay, so you can't use the DS type param to specify just validation data. So what are we going to do? User warning, no split is deprecated. Use split _ none. Alright, here you go. Is that better? Looks like it is. Alright, so wait, where is it? Image cleaner is what it's called now. You've already cleaned your data, run this cell instead. No, I haven't. So let's go ahead and do that. From top losses, so it's called from top losses now. Alright, image cleaner, let's fire it up. DS, ID, indexes, and path. Okay, let's see what that looks like. Ah, cool. Okay. Yeah, that is most definitely not any of these. American black bear. It's an illustration of a black bear, isn't it? Alright, this guy looks like, is this guy black? Doesn't look black to me. It looks like a grizzly. I'm just gonna go with the grizzly here. Alright, next. Oh man. A hunter shot a bear. That's disgusting. Okay, but well, I guess it's still a black bear. Okay, that looks alright. That is a brown. I'm gonna call that a grizzly. Okay, these are all black. Okay, these are black. So at this point, it looks like everything's alright. I'm not gonna mess around with it anymore. Alright, that's a grizzly. I don't know what's going on here. That's 2 of them. So I'm just gonna delete that. And I'm going to delete that one as well. Alright, so, okay, that's just rubbish. Alright, I need to stop obsessing and move on. So at this point, it looks alright. Let's go ahead and run this. Alright, let's play the video.
So I'll just note here that what our San Francisco study group did here was that they actually built a little app inside Google Notebook, which you might not have realized is possible. But not only is it possible, it's actually surprisingly straightforward. And just like everything else, you can hit double question mark to find out the secrets. So here is the source code, okay? And really, if you've done any GUI programming before, it'll look incredibly normal. They're basically callbacks for what happens when you click on a button, where you just do standard Python things, and to actually render it, you just use widgets, and you can lay it out using standard boxes and whatever. So this idea of creating applications inside notebooks is it's really unused, but it's super neat because it lets you create tools for your fellow practitioners, for your fellow experimenters, right? And you can definitely envisage taking this a lot further. In fact, by the time you're watching this on the MOOC, you'll probably find that there's a whole lot more buttons here because we've already got a long list to do, so we're going to add to this particular thing.
All right, that's pretty cool. I didn't know that you could do that. The double control thing is new to me, so let's go ahead and give that a try. So what did they call it? They call it an image cleaner. So let's see what that looks like. All right, so that's the name of the new CSV render. Get widgets. All right, so get widgets now is something. Delete button. Huh. Alright, interesting. Cleaned.csv, that's what it's doing. Cool, okay. Image cleaner. That's pretty nice. It's pretty nice. Alright, cool. So, I think at this point the video is already long enough, so I'm gonna wrap it up and well, let's just see if we can.
So that's it. So I think
this.
I'd love for you to have a think about, now that you know it's possible to write applications in your notebook. What are you going to write? And if you Google for IPy widgets, you can learn about the little GUI framework to find out what kind of widgets you can create and what they look like and how they work and so forth. And you'll find it's actually a pretty complete GUI programming environment you can play with, and this will all work nicely with your models and so forth. It's not a great way to productionize an application because it is sitting inside a notebook. This is really the things which are going to help other practitioners, other experimentalists, and so forth. For productionizing things, you need to actually build a production web app, which we'll look at next.
Okay. All right. So I'm just going to go ahead and wrap it up right now. I think we've gone far enough. So putting your model into production is what we're going to do in the next lesson. And for now, just going to say adios, people. We'll see you soon. Bye-bye.